Hi friends, now let's discuss about the inductive effect. This is the one of the most important method by which the electron density, different electron density centers are created in the molecule. This is the one of the important method of electron displacement methods, right? And most common. In an organic compound, suppose if you have an atom, carbon, it's attached with the chlorine. We know the chlorine is more electronegative atom, and so therefore the electron pair which is shared by these two atoms, the carbon and the chlorine, this electron pair will be slightly closer to the chlorine than the carbon, because chlorine is more electronegative atom, right, than the carbon. So because of that, the chlorine gets a delta negative charge and the carbon gets a small positive charge, right? And by this way the molecule becomes polar. So you get some kind of a polarity, some dipole is produced in the molecule, right? This dipole moment, right, which arises due to the displacement of these electrons, these sigma electrons, right, that's called as an inductive effect, right? So inductive effect means the polarity that is produced in a molecule due to the displacement of sigma electrons, right? Because the bond which is formed by the carbon, the chlorine, that is a sigma bond, and we know the sigma bond is formed by the head-on overlapping of the atomic orbitals, right? So this is also a permanent effect. That means the molecule will always be polar, right? So this is the permanent effect. And this inductive effect, what is the reason you get a polarity in a sigma bond? Due to the difference in the electronegativity, right? One atom must be more electronegative than the other, correct? So this polarity is called as inductive effect. Displacement of sigma electrons, right? Displacement of these sigma electrons here, they go towards the chlorine, then they move from the carbon and they go towards the chlorine slightly. It's not a transfer of electron from carbon to chlorine, it's a slight push, right? Okay, electrons are slightly pulled by the chlorine, slightly. So that's why it gets a delta negative charge and the carbon gets a delta positive charge. In an ionic bond, that's a different one. There's a complete transfer of electron from one atom A to atom B, like the sodium chloride. Sodium loses, the chlorine gains. So there is complete transfer of one electron from atom A to atom B. But in this case, it's not the transfer of electron. It's slightly, electron pair which is shared, this shared electron pair that's slightly closer to the chlorine than the carbon, right? Okay, that's why the chlorine acquires delta negative charge, small negative charge, not the complete one negative charge, right? So delta negative charge and this one delta positive charge, correct? And the one more point, this inductive effect, which is a permanent effect, it can move along the whole carbon chain, right? If you have suppose you have a second carbon here, the carbon number 2, right? These electrons will also be pulled, but this carbon, the carbon number 2, gets a very, very small positive charge. So it does not have a very significant amount of a positive charge as the carbon number 1. So that means this inductive effect can move along the whole carbon chain. But as we move away from the chlorine, right, the charge on the carbon atom decreases. Very, very small, okay? And it's only significant up to carbon number 2. Beyond the carbon number 2, that is insignificant. That's almost negligible, right? It's almost negligible beyond the carbon number 2. Correct? Okay. Now there are different types of effects. There are different types of inductive effects, right? We have different types of inductive effects. Some of the groups, like chlorine, if you attach a chlorine with the carbon, what happens? The carbon takes electrons, right, away from the chlorine. So if you attach a group which takes electrons away from the carbon, it pulls the sigma electrons here it pulls the sigma electrons. So we say this group has a negative inductive effect. A group which can attract the electrons, which can attract the shear pair of electron, that has a negative inductive effect, right? And a group which donates, some of the groups, they can, if you attach a group or atom, right, to the carbon, it can donate electrons rather than taking away. So this group has a positive inductive effect. It has a plus side effect. What are the groups with the which are having negative inductive effect? The groups like these, right? Very, very common. Okay, these nitrogen with 3 methyl groups, NH3 plus, right? NO2, cyanide, COH, fluorine, chlorine, bromine, iodine, right? All these groups, these are having the negative inductive effect. But you can see the decreasing order also. The least one, the hydrogen, right? The least one, the hydrogen. That means, the hydrogen actually, even though there is almost a negligible amount of a difference in the electronegativity between the carbon and the chlorine, so we say almost this carbon hydrogen bond is not polar, or it has almost zero polarity, right? So we take it actually as a reference. That's why you find the hydrogen at the last. Okay, so it has almost a zero polarity. So we take it as a reference. Clear? But some of the groups actually, they are having the positive inductive effect, right? Very interesting. All the alkyl groups, right? If you have an alkyl group, it has a plus side effect. It has electron donation power. Correct? Okay, it's having, it's an electron donor group. The alkyl is an electron donor group, and it donates electrons, right? And this electron donation effect increases with the increase in the number of carbon atoms in the alkyl chain. That means if you have, say for example, an ethyl and a methyl group, right? Okay, this is the one group, ethyl group, and then you have a methyl group, right? Okay, this ethyl has a more inductive effect than the methyl. Correct? So all the alkyl groups, they are having the positive I effect. They are electron donors, right? And their electron donation effect, that depends on the number of carbon atoms, right? Number of carbon atoms. Right? So that means the ethyl group has more than the methyl. Correct? And we can also talk about, suppose if we have a group like this, we have a group like this, CH3, and a CH3, right? This group has much more inductive effect. It contains 4 carbon atoms, right? Okay, it has more inductive effect than these two, than the ethyl and the methyl also. We'll learn about the order of inductive effect, some other groups also in the next video when we discuss about the stability order of the different intermediates. Correct? Fine. So this was inductive effect. It's a polarity, it's a dipole moment which is produced in a molecule due to the displacement of sigma electrons. So that means inductive effect operates through the sigma electrons, and the molecule becomes polar due to the displacement of the sigma electrons. And it's also a permanent effect. It always occurs in a molecule. It always remains in a molecule. A molecule always remains polar due to the difference in the electronegativity. Okay? And some of the groups are having the positive inductive effect, some of the groups are having the negative inductive effect. A group which can donate electrons to the carbon, that's a positive inductive effect, plus I effect. A group which withdraws electrons from the carbon, that's a negative inductive effect, right? Now what is the application of this inductive effect? That's the most important thing. That's what you will be asking in all your exams. Application of inductive effect. That's very important point. The most important application of this inductive effect is that we can explain the stability of the different intermediates that we discussed in the last time, right? In the last video, we discussed the different intermediates. What are intermediates and what are the different types of intermediates, right? Like carbocations, carbanions. And the first important application of this is that we can explain the stability of the different types of intermediates. Say we have an example of a carbocation, right? So we have example of a carbocation. We know the carbocation is the carbon with a positive charge, right? Okay. So if you have a methyl group attached to this one, right? Now this is the carbocation. This is the one carbocation. Let's take another carbocation. Let's take this carbocation, which has only two methyl groups attached and a one hydrogen atom. And let's talk about another carbocation with only one methyl group attached, right? Now this is called as the tertiary carbocation. This is the secondary carbocation, and this is the primary carbocation. According to the inductive effect, we can explain which one is more stable. The tertiary is more stable than secondary than primary. Why? Because carbocation we know is electron deficient, and alkyl group in general we know they are electron donors, right? They can donate electrons. Okay, they can donate electrons to the carbocation, and if they donate electrons to the carbocation, they will decrease the electron deficiency of the carbocation. That means methyl group attached to the carbocation increases the stability. But in the secondary there are only two methyl groups. The hydrogen does not have a much inductive effect, very less inductive effect it has. Okay, but for the secondary there are two, for tertiary there are three, for primary there is only one, right? So that means the most stable one will be the tertiary, then the secondary, then the primary. So that means we will discuss about the intermediates later on. This was just an example that inductive effect we can explain the stability, right? We can explain the stability of reaction intermediates, right? With the inductive effect we can give the order of the stability of the different intermediates. Stability of the different intermediates. We can explain the stability of the intermediates. Okay, we'll discuss about all the intermediates later on in a separate topic and a separate video. Another application of this inductive effect is that we can explain the acidic nature, right? Okay, acidic nature of the different organic acids. Like we have a phenol. The phenol is more acidic than the alcohols. Similarly, carboxylic acids are more acidic than phenols, right? So we can explain all these things with the help of inductive effect, right? Let's take an example here. Say for example we have a formic acid and the acetic acid, right? A very common example, formic acid and the acetic acid. This is an acetic acid and the formic acid is this one, correct? Okay, when formic acid dissociates and it produces the CH3CO O negative ion, and this one also dissociates and forms the HC double bond O negative. We have to understand, we'll discuss all about the acidic nature in other videos also, but just an example here. The formic acid is a stronger acid than acetic acid. Why? Because the conjugate base of this formic acid is more stable than the acetic acid conjugate base, right? Why? Because in the acetic acid you have a methyl group attached to this and its electron donor, and that electron donor increase the density on the oxygen. Here we have a hydrogen, and hydrogen does not donate, so therefore the electron density on this particular oxygen is not so high. Correct? That means higher electron density, this plus I effect of the methyl decreases the stability of this conjugate base of this one, of the acetic acid, and that's why this is less stable. Correct? That's why this is less acidic. While the formic acid is more stronger acid because it has a hydrogen rather than methyl. So methyl has a more electron donation effect than hydrogen. So that's why the formic acid is more stronger acid than the acetic acid, because the conjugate base of the formic acid is more stable. And this we can explain with the help of inductive effect, right? Hope you got the concept. See you in the next video. Bye.